Hi, Cecilia. Can you hear me? All right. So we are going to go ahead and get started. Um, so this is the Statistics Chapter 6 review session for the 8-week course. And yeah, so we're just going to go ahead and dive in. So this chapter, you're going to be doing most of it on your calculator. So we're definitely going to go through how to do things on the calculator, but there's still plenty of things that you're going to need to know which formula to use. So we're going to go through and make sure that it's clear, how you determine which formula to use and how to determine which menu in the calculator to use. So, all right, so for this first one, remember, as you read through the questions, you want to start labeling things as they're given to you. So the grade point average collected from a random sample of 150 students. So right off the bat, I know N is 150. That's the number of students in the sample. That sample produced a mean of 2.86. So it was the sample that produced that mean. So that means it is a sample mean, or X bar, of 2.86. Assume that the population standard deviation is 0.78. So they have provided us with that. And then they want us to construct a confidence interval for the population mean if C equals 0.98. So C, or the confidence level, is 0.98. So, oh yes, yeah, you're at work again. So if you leave, that's why. No problem. I will email you the link. Oh, also, Cecilia and Kendra, this session is being recorded, so I will be emailing the link if you want to. I think, Cecilia, I already have your email address, but yeah, if you guys want me to email you the link, put your email address in the chat, or email me directly. I will actually, you know what, I'm going to put my email address in the chat here so that you can just email me directly if you don't want to put it in the chat. So you can actually email me directly at you. Okay, and then yeah, Kendra, thanks for providing that. I'll send the link afterwards, and that way you guys can go through these at your leisure if you have to leave for any reason or if you want to look through the problems again. All right, so we've written down a bunch of information, and now what we need to do is decide what we're plugging into the calculator. What menu are we going to? So before we do that, just a quick reminder of when we plug this into the calculator, what are we actually finding? So we have to keep in mind that we're trying to find the confidence interval for the population mean. That's the mu. And it is somewhere between the sample mean plus some margin of error and the sample mean minus some margin of error, right? So we've got the population is somewhere in between there. There is a great image in your textbook, and I'm going to pull this up here because I think it describes really well a very good visual of what we're actually doing when we do this. So this right here, so this is on page 303, if you're looking in your textbook. So the horizontal segments represent 90% confidence intervals for different samples of the same size. In the long run, 9 out of every 10 such intervals will contain the population mean, right? So like this one doesn't contain it, right? The population mean is right here. So here are a bunch of different samples, and 9 out of 10 of them contain the mean. So when we're talking about finding confidence intervals, this is what we're doing, is we're saying we can be 90% confident that the mean is going to be in the particular range that we found. Okay. All right. Okay. So You can do this by hand, right? There are formulas that you're provided in the book, and I'm sure they walk you through them, but mostly you're just going to be plugging it into the calculator. However, it's important to know that these formulas exist because you need to understand the relationship between what we're looking at here, right? Like if you're given the upper number of the interval, you need to be understanding that that is your sample mean plus some margin of error. And I think there's a problem later in this review session where it has you calculate that. So okay, let's take a look at what we're going to be doing in the calculator. So we have different situations, okay? We either have that the population standard deviation is known, or we have that the population standard deviation is unknown. And these are for when we're trying to find confidence intervals about the population mean. And then we also have when we're trying to find information about a population proportion. Okay, so we're going to use different menus in the calculator for these three situations. And as we go through, we'll talk about some very specific criteria that need to be met. But for right now, let's just talk about which menu items to use, because you have to make sure that you're confident, no pun intended, on which one you're using, right? So when we are provided with a population standard deviation, not a sample standard deviation, which is S, but a population standard deviation, which is sigma, then what we're going to do is we're going to go to stat and test, and then we're going to choose number 7, which is the Z interval. Oops, let me scooch that over so you can actually see that. Okay, so if we don't know, unknown, if we don't know the population standard deviation, then instead of using a Z interval, we're going to be using a T interval. So we start the same, where we say stat and then test, but then we're going to go to number 8, which is T interval. Okay. And then our other situation, if we're looking for the population proportion, okay, then we're going to go to, again, the first part is the same, stat, test, but we're going to do A, or alpha, 1 prop Z int. 1 prop Z int. Okay, so that's proportion, right? This is population proportion, Z interval. That's what that stands for. Okay, so let's take a look at what we have. So they're asking us to construct a confidence interval for the population mean. So we know we're going to be doing one of these. And they did give us the population standard deviation, right? They didn't say that, oh, the standard deviation from the sample was this. They said specifically the population standard deviation. So that means our population standard deviation is known. So once we write down everything here, we're going to go into stat, this up just a little bit here. So stat right here, and then test. You can either arrow to the right 2 times, or if you were here on edit, you could arrow to the left and it like circles back around over to the right to tests. And we're going to go to number 7, Z interval. So again, you can arrow down to number 7 and hit enter, or when you're up here at the top, you can just hit number 7 and it will go directly to that. Okay, so the next thing is that you have to tell the calculator if you're going to be giving it raw data or if you are going to be plugging in specific statistics to it. So if we were to have selected data, we've got to tell it where that data lives, right? We've got to give it the list and, you know, potentially the frequency list. But for most of the well, for all the problems that I've seen on this, I'm pretty sure you guys are only going to be using this one right here, the stats. Okay, so we have to provide it with these values. So the first thing is the population standard deviation. So what did we say ours was? 0.78. Okay, then we have the sample mean, 2.86. And our N, our sample size, 150. Okay, the confidence level, they wanted 98%, so 0.98. And then we're going to go over calculate, and we're going to hit enter. Okay, so it just spits out our final answer, right? But keep in mind what this means. This means that the population mean is, I'm sorry, that we can say with 98% confidence that the population mean of grade point average for these students is between 2.71 and 3.01. Okay. So always make sure that you're understanding what it is that you're finding. Okay. Number 2, in a sample of 10 randomly selected women, so sample of 10 women, that means we have an N of 10, right? It was found that their mean height, so the sample mean, was 63.4. From previous studies, it can be assumed that the population standard deviation, and they even give you the symbol sigma there, is 2.4, and that the population of height measurements is normally distributed. Construct the 95% confidence interval for the population mean. Sorry, I didn't realize that was not visible. I'm going to zoom in just a little bit more here. Okay, so in future problems, we're going to talk about why that's important. But for right now, let's just go through and plug these in. So again, how do we do this? We say that, all right, we're trying to find a population confidence interval, population mean, right? So again, this is our sample mean plus some margin of error, and our sample mean minus some margin of error. Okay, so they said a 95% confidence interval. So our C is 0.95. So we go back to, if we know our population standard deviation, this is a Z interval. We were given our population standard deviation, so this is a Z interval. So that's what we're going to provide. I feel like this is not very bright. Okay, there we go. So again, we're going to go stat, test, and then number 7, Z interval. And we're going to plug in the corresponding information. So our population standard deviation in this is 2.4. Sample mean is 63.4. Sample size is 10. And confidence level is 0.95. Actually, you know what? I think I am going to talk about it right now, why it's so important that this is normally distributed. So first of all, let's get our final numbers here, right? We're saying that our population mean is between 61.9 and 64.9 when we round. We need to make sure we're saying it the right way, right? We are 95% confident that our population mean is between these two values. Okay, so yes, let's go back and let's talk about why that's so important that they specified that it's normally distributed. So on page, let's see, this is page 301 of your textbook. So let's take a look here, page 301. All right. So the guidelines here, I know this looks like a lot, but if we break it down, what it's telling us is if we were to do these step by step by hand, how to do it. The important thing that I want to draw your attention to here is this first thing here. We need to verify that we can actually do this, that we're actually allowed to, that we meet the criteria. So verify that our population standard deviation is known. Okay, check. Yeah, we were given that. The sample is random. I believe it said that in it. Yeah, a sample of 10 randomly selected women. So check. That's random. And then and then it gives us two different things. So this either means we can do one or the other. It's great if we've done both, but we don't have to do both. We can do one or the other. So we need to meet one of these two criteria. Either the population is normally distributed, or if the population isn't normally distributed, that's okay, as long as our sample size is 30 or more, right? N is greater than or equal to 30. And then it goes the other way too, right? So if our sample size is not 30 or more, like for instance, if our sample size is 10, like it is here, then we're only allowed to do this if we meet the other criteria, if we are normally distributed, right? So this step right here is a checklist that you have to go through to make sure that you can actually use the stat test number 7 and actually plug it in that way. Okay, because sometimes you won't be allowed to. Okay. All right, yeah, so then we got our numbers. Again, always make sure that you understand what you found. We're 95% confident that the population mean falls between these two values. Okay. Number 3, a nurse at a local hospital is interested in estimating the birth weight of infants. How large a sample must she select if she desires to be 99% confident? So our confidence level needs to be 99% or 0.99. That the true mean, right, the population mean, is within 2 ounces of the sample mean. So what did they just give us here? They just gave us the error. The margin of error is 2. The population standard deviation of the birth weights is known. Okay, great. Population standard deviation of birth weights is known to be 7 ounces. Okay, great. So we're not finding a confidence interval. We're finding a sample size, right? That's what it's asking. How large a sample must she select? So we have to know which formula we're going to use. So again, we were provided a population standard deviation. So that tells us that we are using this formula right here. Okay, so finding a minimum sample size to establish your population mean. Okay, so a couple things to note here is that when you don't know your population mean, you can estimate it using your population standard deviation, apologies. When you don't know your population standard deviation, you can estimate it using your sample standard deviation only as long as you have a preliminary random sample with at least 30 members, right? We keep seeing that a lot, and greater than or equal to 30, okay? So this is one of the problems where you're going to have to actually plug some things into a calculator. Or I'm sorry, where you're going to have to actually plug some things into a formula instead of just having the calculator do it for you. Okay, so let's copy the formula down that we're going to be using. All right, our formula is N equals the z-score that corresponds to that confidence level times our population standard deviation over our margin of error squared. Okay, so let's talk about how to get everything in this formula. Okay, because very first thing that we need is this z-score. So how do we get this z-score? The z-score is going to be dependent on your confidence level. Okay, so in your book, I'm going to show you where it gives a little sort of cheat sheet here. So the difference between z-scores when we're talking about confidence intervals and z-scores from previous chapters is that this confidence percentage here, this number, is the area under the curve in the center. Okay. So this area, this middle area, is 0.99, not the whole area to the left, just the area in the middle. Okay. So that's different from what we had in previous chapters. So if I did need to know the area to the left, then what I would need to do is I would need to say, okay, well, if this is 99%, what would both of these be together, both of these tails? So these tails together would have to make up the other 1%. Okay, well, if both of the tails together make up 1%, then that means each individual tail is 0.5%. So if I needed to know the whole area to the left rather than just the area in the center, I need to do 0.99 plus 0.005. So this whole area all the way over is 0.995. Okay. So we're going to show you how to look that up in the book 2 ways, and then how to find that in the calculator a couple of ways. So in your book, in the appendix, here, I'm going to zoom out so that you can see the whole page for a second here. Sorry, I don't have a lot of room on this desk. So we've got our standard normal distribution. And then at the bottom of that page, it gives us critical values. And you can see that it's reminding you that when we're talking about levels of confidence, we're talking about an area in the middle with 2 tails. Okay. So if we zoom in on that, this light keeps turning off. There we go. It gives some common confidence levels here, right? So our confidence level was 0.99. So it's telling us that our corresponding z-score is 2.575. Okay, so real quick, I'm just going to write that. Oops. I'm going to write that here, that our corresponding z-score is 2.575. 575. All right, but now we're going to look up, okay, what if I completely forgot that I can use this and I was just trying to look it up here? So I would have to remember that I'm looking for an area under the curve of 0.995, right? Because remember, that's what these tables give, is the full area to the left. So we need to look up an area of 0.995. So you go 0.995. It's directly in between 0.9949 and 0.9951. It's halfway in between those. So I go to the left and I say that's 2.5, and then I go up and it's 0.07, between 0.07 and 0.8, so that's 0.075. Hold on. I'm just trying to get 0.9. Oh, my apologies, 0.99. I don't know what I was looking up, but it needed to be 0.99. Oh, yeah. Yeah, that is what I was looking up. Oh, I'm sorry. No, 0.995. 0.995. Because the area is 0.99 and then we have 0.005, so 0.995. So either way, we're getting the z-score of 2.575. 575. Okay. Sorry, having this book moving back and forth. It's a bit much. All right. So how would we find that on our calculator? Okay. So if I didn't want to look it up in the table, what I can do is I can say second vars, okay, and we're going to go inverse norm, and we can say that we want the center. So the area in the center of 0.99. So we can specify that we want it to be in the center, right? And we're getting 2.575. Now it's also giving us the negative value, right? It's giving us this z-score and this negative z-score, but we're just going to use the positive. I mean, if we use the negative, it wouldn't matter because we're squaring it, so we'd still end up with a positive, and it's just easier to plug in positive numbers. So we're still getting 2.575. But let's say that, you know, you were given this, so we would go second vars inverse norm, and maybe your calculator doesn't have the ability to do the center, and it only has the ability to do the area to the left. Then you have to tell it that it's 0.995 if all it can do is the area to the left. Okay, and you're still ending up with 2.575. Okay, so you have several options for how to get your corresponding z-score, but whichever option you choose, you're getting the same z-score. Okay, now that we have that, now we can plug it into the formula. I feel like it's not focusing very well. If we go in a little bit more. There we go, that's a little better. All right, so we have n is equal to 2.575 times our population standard deviation, which is 7, over our margin of error, which is 2. We're taking all that and we're squaring it. Okay. So when I go to plug this into the calculator, I want to make sure that I'm just being careful with like order of operations. And I mean, if I wanted to, I could kind of do this like step by step. Maybe I do that and then I square it. Or, you know, if I wanted to do it all at once, I mean, this is just multiplication and division, so it's actually going to be okay. But we're going to be getting an n value of 81.225, blah, 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 blah. So what exactly does this mean? What are we looking for? What is n? N is our minimum sample size. So n represents how many people, or in this case, how many infants we need to have in this study. Can I have 0.225 of a person? No, I cannot, which is why your n always needs to be a whole number when you're dealing with choosing people, okay? So then what we do is we have to take this number and we have to go up to the next whole number. Not because of any sort of rounding rule, because if we're just using normal rounding rules, this would actually go down to 81, but because this number represents the bare minimum sample size that we are required to have. Well, if I go down to 81, I haven't hit this threshold. If I only include 81 people in the study, then that's not enough. So I have to go up to the next whole number, right? That's why we have to go up to the next whole number, because we're dealing with actual people and we need to have at least this many, and we can't have part of a person, so we got to have a little bit more. But also keep in mind, this is the minimum sample size that's needed. You can absolutely have more than this. In fact, you should have as many people as you can include, realistically. Yeah, so that's why we have to go up to the next whole number. Even if it's just a tiny bit over, even if this was 81.001, you still have to go up to 82. Okay. All right. Moving on. Okay, which statistic is the best unbiased estimator for the population mean? And the answer to that is the sample mean. So say sample mean, right? And the symbol for that is X bar, right? That's how we say that, X bar. So they're just wanting to remind you that the best unbiased estimator for the mean, for the population mean, is the sample mean, right? That's why we say, well, the population mean is, let's use the sample mean as a starting point and then either add the error or subtract the error to get the number on the left and the number on the right that will give us our confidence interval, because that's the best estimate. So we start with that and then do a margin of error more and a margin of error less. Okay, construct the confidence interval for the population mean, and it provides us a bunch of things. So it has just provided us with a population standard deviation. So remember from our first page here, when we know our population standard deviation, when that is known, we're using a z-interval. So we're going to plug these things into the calculator. Again, we go to Stat, we go to Tests, and our z-interval is number 7. All right, so population standard deviation is 0.5. Sample mean is 5.3. N, or sample size, is 58. And our confidence level is 0.98. And it spits out our confidence interval. So we can be 98% confident that the population mean is between these two values. And again, rounding to 2 decimals, just make sure if they give you directions on how to round, make sure you're actually following those directions. Quick recap for how to round. So it says round to 2 decimal places. You're going to underline the second decimal place. You're going to underline how many places they say to go to. So the last of the number of places they say to go to. So I'm going to underline my second digit. You're going to look to the number to the right. If that number is 5 or more, the number you underlined goes up 1. If that number is less than 5, your number stays the same. So the only thing you're going to change is the number that you've underlined, and then you're going to get rid of the digits to the right. So 4 will increase to 5 because this is 5 or more. So we have 5.15, which is what they have there. One exception to this is the only thing that you'll change. Let's say we had something like that, and they wanted you to go to 2 decimal places. So you would look to the number to the right. This is 5 or more, so this needs to go up 1. Well, if this goes up 1, that has to go up 1. So you would make sure to go to 2 decimal places. So quick reminder on that. You don't want to get a problem wrong because you had the incorrect number of decimal places or because you accidentally rounded wrong. So you do all this work, you know which menu in the calculator to go to, and then you round wrong. Don't want to get it wrong because of that. Okay, number 6. You are given the sample mean and the population standard deviation. Use this information to construct the 90 and 95% confidence intervals for the population mean. Interpret the results and compare the widths of the confidence intervals. Okay, from a random sample of 40 business days, that's our N, okay. Also notice they said random sample, right? We have a random sample, that's great. Also our N is more than 30, so that's great. The mean closing price of a certain stock was 117.61. So the mean of that sample, so the sample mean, was 117.61. Assume the population standard deviation, so sigma population standard deviation, is 10.23. Okay, so again, what are we given? That tells us what menu to use. There we go. What are we given? Population standard deviation is known, so that's going to be a z interval. We will get to some t intervals, but so far it's just z intervals. Okay, so we're going to do the 90% confidence interval first. Stat, test, number 7, Z interval. Our population standard deviation is 10.23. Our sample mean is 117.61. Our N, our sample size, is 40. And our confidence level, we're going to start with the 90% confidence level. Okay, so again, they said to round to 2 decimal places. So we put those numbers in. Okay, now we're going to do the exact same thing, but with a C value of 0.95. Also, side note, notice that every time that it gives me it in a percentage, you have to write it as a decimal, right? So if your confidence level is 95%, you have to write that as 0.95. Don't forget that you have to write that as a decimal. So we're going to go back, we're going to go stat, tests, number 7, the Z interval. And the only thing we're going to change here is that we want to be a little bit more confident. So instead of being 90% confident, we want to be 95% confident. Okay, and then it gives us new numbers. Okay, so which interval is wider? So picture these on a number line, right? So we have some number in the middle, we've got 114.95, and then we've got 120.27, right? This is for the 90% confidence level. So 114.44, well, that's a little bit to the left, right? That's not quite as big as that. So it's a little bit lower. And then 120.78, well, that's a little bit more than that number, right? So it's a little bit farther along, 120.78. Right, do you see how I did that? We've got a number line, goes from 0. If 114.95 is here, where is 114.44 in relation to that? It's a little bit to the left because it's less than that. Okay, so which interval is wider? This interval, this second one, the 95% confidence interval, is wider. Okay, because we want to be more confident, so we have to expand our interval. If we're not worried about being quite as confident, we can lower our interval. Okay, and then interpret the results. You can be 90% confident that the population mean price of the stock is between the bounds of the 90% interval, and you can be 95% confident for the 95% interval. I know a lot of this chapter is just plugging things into the calculator, but it is important to understand the bigger picture of what you're actually finding and what it means. So, okay, number 7, you are given the sample mean and the population standard deviation. Use this information to construct the 90 and 95% confidence intervals for the population mean. Interpret the results, compare the widths of the confidence intervals. So similar problem, right? I'm gonna move this down a little. I feel like there's not enough light here. Okay, so from a random sample of 36 months, random sample, that's great. And we have 36 months, so our N is greater than or equal to 30, so that's great. From January 2006 through December of 2020, the mean number of tornadoes per month in the United States was about 97. So from that sample, the mean was 97. Assume the population standard deviation is 112. So again, we were given our population standard deviation, which means that we can use number 7, the Z interval. Okay, so we're going to do that for both the C value of 0.90 and the C value of 0.95. So we go stat, tests, number 7, we plug in our information. Also, just make sure you're going carefully through this. A lot of times the first number that they give you in the problem is your n value. So if you're writing them down in order, you have n first. Don't fall into the trap of plugging in n first, because the first thing here is not the n. The first thing here is the population standard deviation. So just make sure that you're being extra careful and plugging things in where they belong. Okay, so we're going to start with the confidence level of 90%. Okay, so we get our numbers, we round to 2 decimal places. Now we're going to do the same with 95. So again, stat, tests, z interval, and the same numbers, but the only thing we're changing is that we want to be a little bit more sure. We want to increase our confidence level. And we get these numbers. Now, before we look at which one's wider, we can say that I'm betting that this interval is going to be wider. If I'm more sure, I have to cover a broader range of numbers, right? So again, if we were to do this on a number line, the 90% confidence interval as compared to the 95% confidence interval. So, okay, we have 66.30 and 127.70. Okay, 60.41 as compared to 66.3. So, oh, I'm sorry, yeah, 60. I was reading that as 66. It's 60.41, so it's much lower, right? 60.41. 127.70 versus 133.59. If 127.70 is here, 133.59 is somewhere to the right of that on the number line, right? So this is a much wider interval as we increase our confidence level. And then again, interpret the results. We can be 90% confident that the population mean number of tornadoes is between the bounds of the 90% interval, and 95% confident that the population mean number of tornadoes is between the 95% interval. All right, number 8, if all other qualities remain the same, how does the indicated change affect the width of the confidence interval? Okay, so if we increase the level of confidence, as we just saw, we have to widen the confidence interval. Okay, we have to cover a broader range of numbers if we want to be extra sure that it really does include the actual population mean. All right, how does an increase in the sample size affect the width of the confidence interval? So if we increase the sample size, it's going to narrow the confidence interval. It will narrow the confidence interval. So if you have a sample of just 30 people, you're not going to be super confident. But if you expand your study and you do a sample of 3,000 people or 3 million people, you're going to increase your confidence, right? One way that I like to think about this, if we think back to when we were doing probability, I forget which chapter that was, and they were talking about how we know that there's a 50-50 chance of getting heads or tails if I flip a coin. But if I flip a coin 10 times, I'm not necessarily going to get 5 heads and 5 tails. But the more I flip a coin, the larger my sample size, the closer the actual percentage that I'm getting is going to get to the theoretical percentage, right? If I flip a coin 3 million times, it's going to be pretty darn close to 50-50. But if I only flip a coin 2 times, it could be pretty far from 50-50. I might get 2 heads in a row, right? So that's kind of how you want to think of this. So if we increase our sample size, the confidence interval, we're narrowing the breadth of numbers we are looking at. We can say, hey, I can focus in and say that I can be confident that it's somewhere in this smaller range of numbers. I don't have to look at such a wide range of numbers to say that it could contain my population mean. I can look at a much smaller range of numbers And I can be confident that that small range of numbers is going to contain my population mean. And then the last one, an increase in the population standard deviation will widen the confidence interval. So remember, population standard deviation, you can kind of think of it as like, well, how much variation, right? It's related to variance. How much variation is happening in my population? If there's a lot of variance, then that's we're having to widen the confidence interval. We got to broaden our horizons here to make sure that we actually include the number if there's a lot of variation. Okay. Number 9, construct a 95% confidence interval for the population mean. Assume the population has a normal distribution. Great. A random sample of 16 fluorescent light bulbs, N, 16, has a mean life of 645 hours with a standard deviation of 31 hours. Well, that's sample standard deviation. That's S, right? Because it was that sample that had a standard deviation of 31 hours. So going back to what we said here at the beginning, our population standard deviation is unknown, so we have to use a T interval. Okay. All right. So let's take a quick look at what the requirements are for that. Go back to the guidelines in the book, right? So this is for when our population standard deviation is unknown. So again, we need to verify a few things. Okay, verify the population standard deviation is not known. Check, not known in this one. The sample is random. Did it say the sample was random? Yes, it did. It said a random sample of this many light bulbs. Okay, and either, so again, we have to hit one of these two categories here. It's great if we hit both, but we just need to hit one. Either the population is normally distributed, it has a normal distribution, so check. So we are good. So we don't even need to look at the next category. But if we wanted to, we could. Or n is greater than or equal to 30. Well, you know what? In our case, n is not greater than or equal to 30, but that's okay because we only need to check one of these two categories here. Either it has to be normally distributed, or if it's not, that's okay as long as we have a big enough sample size. Or in our case, it's okay that we have a small sample size. Our sample size is not greater than or equal to 30. That's okay because the population is normally distributed, right? It's got to be one of those two. Okay. So, all right. So we have labeled everything. We need our confidence level of 0.95, right? Again, you have to write it as a decimal. Okay. So we are going into stat, test, and instead of number 7, we're going to be going into number 8, which is the T interval. Now again, real quick, in the book, if you wanted to look at what your T distributions, look like. So the T distributions, they know that you're mostly coming here because we're talking about confidence levels, right? That's what we're here for. So they're like, yeah, we're looking at the area in the middle. We've already calculated, you know, hey, if you want to know what one tail and what two tail is, but here's your level of confidence. And then we have to look at the degrees of freedom. Okay, so remember, degrees of freedom is n minus 1, so your sample size minus 1. So if you're doing this by hand, if you're doing this in the table, don't forget, degrees of freedom is not your sample size, it's your sample size minus 1. And then you would go and look the number up that way. But in our case, we're just going to have the calculator do it for us, right? Sorry, really have no room on this desk. Okay. Zoom out here a little bit. Okay, so we're going to go to Stat, Tests, and this time we're going to number 8, T interval. Okay, again, if you're on data, make sure that you're over onto Stats. All right, we give it our sample size, or I'm sorry, our sample mean, which is 645. Our sample standard deviation, which is 31. Our sample size, which is 16, and our confidence level, which is 0.95. And it's going to spit out the number for us again, making sure to round to the number of decimal points that they have in the answer. But generally, you're going to find that your answer is going to be one more decimal point than the data that you were given, right? Okay, so again, if we don't know our population standard deviation, then we are using a T interval, right? Make sure that you know this. If we know our population standard deviation, we're using Z. If we don't know our population standard deviation, we're using T. And if we're talking about a population proportion, we use 1 prop Z int. Okay, moving on. Construct a 90% confidence interval for the population mean. Confidence level, 90%. Assume the population has a normal distribution. Okay, great. In a recent study of 22 eighth graders, okay, N is 22, the mean number of hours per week they watched television of that sample mean, was 19.6 with a standard deviation of 5.8. So that was a sample standard deviation. So again, we don't know our population standard deviation. We only know our sample standard deviation. So we're going to use a T interval. Okay, so we go stat, tests, and then we go number 8, T interval. Make sure you're on stats rather than data and plug in the numbers that we have. 19.6, sample standard deviation is 5.8, sample size is 22, confidence level is 0.9. All right, so again, we are 90% confident that the population mean falls between 17.47 and 21.73. Okay. Number 11, construct a 99% confidence interval for the population mean. Assume the population has a normal distribution. A group of 19 randomly selected employees, so N is 19, has a mean age, that sample mean is 22.4, and that sample standard deviation is 3.8, round to the nearest tenth. Confidence level of 0.99. So again, plug and chug, right? We know that we have, instead of a population standard deviation, we have a sample standard deviation. So that tells us we're going to be doing our T interval. So we do stat, test, number 8, T interval, and plug in what we have. Sample mean, 22.4, sample standard deviation, 3.8, sample size, only 19. Again, it's okay that we have a sample size that's less than 30 because the population is normally distributed, right? It's got to be one or the other. It's great if it's both, but it's got to be at least one of those. And oops, did I put something in wrong? Let me go back. Stat, test, T interval. Sample mean 22.4, 3.8, 19. Oh, yes, because I put 9 and we want 0.99. So that's why I got a slightly different answer, because I was not looking at the same confidence level. All right, so that's how we get the same number they got. Okay. Number 12. A random sample of 40 college students has a mean earnings of 3120 over the summer months, assume the population standard deviation of earnings over the summer months for the college students is 677, and that the distribution of earnings over the summer months for college students is normally distributed. Determine whether a normal distribution or a t-distribution should be used, or whether neither of these can be used to construct a confidence interval. Okay, so they gave us a population standard deviation. So we know that if we're allowed to, we're going to be using the z-interval, right? We're always coming back to this. If we know our population standard deviation, we're going to be using a z-interval. But we have to check that we have actually met all of the requirements to be able to use the z-interval. So again, we go back and we say, well, what are those requirements? The requirements are that we know the population standard deviation, check. The sample is random. Did they tell us that it was a random sample? They sure did. Okay, check, random sample. And then either that the population is normally distributed or our sample size is greater than or equal to 30. Population is normally distributed, so check for that. So even if n was less than 30, we'd be okay because it's normally distributed. So that's why we can, yes, use a normal distribution. Okay. All right, a random sample of 15 statistics textbooks has a mean price of 105 with a standard deviation, so that's a sample standard deviation of 30.25. Determine whether normal or t, so same question as last time. So they've given us a sample standard deviation, not a population standard deviation. So we're checking, do we meet all the criteria to use a t interval? Because we don't know our population standard deviation. So again, we go back to what are the criteria for using the t-distribution, right? So I would suggest making yourself a little checklist, right? That certainly makes this easier. Okay, population standard deviation is not known. Check. The sample is random. They said yes, random sample. Check. And then again, we have to meet one of these two criteria. Either the population is normally distributed, or if it's not, we need to have a sample size greater than or equal to 30. Or other way around, either the sample size has to be greater than or equal to 30, or if not, that's okay, as long as it's normally distributed. So our sample size is not greater than or equal to 30. So we need to make sure that this is normally distributed in order to use this. But it says assume the distribution of statistics textbook prices is not normally distributed. So we can't check off something from that third category. So we can't use a normal or a t-distribution. Okay. So again, you're checking, is this known or is it unknown? Okay. Then for both of them, it needs to be a random sample, right? And then it needs to either be n of greater than or equal to 30 or normally distributed, right? Either n is greater than or equal to 30 or normally distributed, right? So this one, we have an unknown population standard deviation. Okay. It is a random sample, and one of these needs to be true. Neither of them are true. So unless we can check off every category, we can't use these. All right. So we've only got about 10 problems left. So we're gonna kind of fly through some of these because some of these are very similar to what we've done already. Okay, so construct the indicated confidence interval for the population mean using the t distribution. So they just come out and tell you which one to use. Even if they didn't tell you which one to use, they've provided the sample standard deviation, so that's how we know which one to use. And they're comforting you, letting you know, hey, it's okay to use it because it is normally distributed because our sample size is less than 30. They're saying, hey, I promise you can actually do this. You're allowed to. So again, stat tests, because we have a sample standard deviation rather than a population standard deviation, we're using number 8, the t interval. We're going to plug in what we know. The sample mean is 12.3. The sample standard deviation is 0.93. The sample size is 19, and our confidence level is 0.98. And then we round as they ask us to. Okay, in a random sample of 22 people, the mean N is 22, right? The mean commute time to work in this sample mean, was 34.5 minutes. And in that sample standard deviation, it was 7.1 minutes. Assume the population is normally distributed. Great. Use a t distribution. Even if they didn't tell us that, we would know because we have a sample standard deviation rather than a population standard deviation to construct a 95% confidence interval for the population mean. And then they want us to find the margin of error. So this first part is going to be same as what we've been doing. Stat, test, because this is a t distribution, we're going to do number 8 t interval. Plug in what we know. Sample mean 34.5. Sample standard deviation 7.1. Sample size of 22. Again, it's okay that we have a sample size that's less than 30 because it's normally distributed. That's why that's okay. And then we have a confidence level of 95%. Okay, so we get these numbers, great. But then they want us to find the margin of error. So this is where we have to remember, what the heck did we just find here? What we just found is that the population mean is, that we are 95% confident that the population mean is between 31.4 and 37.6. But what were each of those things? Each of these things was the sample mean plus some margin of error. And over here, the sample mean minus some margin of error, right? So this number right here, if we were to have done this by hand, we would have taken the sample mean, which they gave us, and we would have added a margin of error, which we would have calculated, right? We have a formula for calculating the margin of error. So we don't necessarily have to use the formula to calculate the margin of error if we know what this plus this is equal to, right? If the mean plus the margin of error is equal to 37.6, and we know what the mean is, right? The mean is 34.5, then we can easily calculate the margin of error. So you can either just kind of do this in your head, or you can say, oh, I've got an equation here. I'm going to solve this equation. I'm going to move the 34.5 to the other side of the equation, and that's how I'm going to get that the margin of error is 3.1. All right, I'm going to do 37.6 minus 34.5. That's going to get me 3.1. Or if you don't want to think, if this feels too complicated, just remember that this number is the mean plus something. So what do I have to add to the mean to get 37.6? Okay. If you did want to do it by hand, you could. My suggestion would be that you've already calculated this in your calculator, so it's going to be faster to just do it this way. If you did want to do it by hand, remember that your formula is the formula for the margin of error when we're using the t distribution is the t-score times the sample standard deviation over the square root of the sample size. So you've got to calculate your t-value. So you can either do that, you know, by looking it up in the table, right? Or if you wanted to do it on the calculator, we go second vars and then inverse t. So remember, when we're talking about the t scores rather than the z scores, we have to keep in mind our degrees of freedom. So the area is, what was the confidence interval here? 95, right? The degrees of freedom is n minus 1, right? Not n, but n minus 1. So our sample size is 22, so our degrees of freedom is 21. Okay. Oop. Oop. I put 95 instead of 0.95. That's why it didn't like that. Nope. What did I do? Honestly, I don't think you're going to need to do this anyway. You're not going to need to do this anyway. I'll come back to that later if we need to, but you guys aren't going to be doing this by hand anyway. And to be honest, it's probably easier to just look up in the table, because when you're taking the test, you're probably going to have your table right there next to you, or it's going to be you know, available for you to click on. But we'll come back to that if we need to. Okay, so either way, we have found that our error is the 3.1, and then they want us to interpret the results. Again, we're making sure that we're wording it the same way every time. We can say with 95% confidence, or with 95% confidence, it can be said that the population mean commute time is between the bounds of the confidence interval. All right, use the standard normal distribution or the t-distribution, so we have to decide which one we're using, to construct a 95% confidence interval for the population mean. Justify your decision. If neither can be used, explain why. Interpret the results. Okay, so random sample of 11 mortgage institutions. The mean of that sample, interest rate, is 3.52%. And the standard deviation of that sample is 0.41%. Now, if you wanted to change these to percentages, to 0.0352 and 0.041, you could do that. You would just have to remember that the number that you're getting is in decimal form. I'm choosing to leave them this way so that I can just say 3.52% rather than looking at this and saying, okay, what is that in percent? That's 3.52. Okay. Assume the interest rates are normally distributed. Thank goodness they're normally distributed because my n is only 11. So if my n is less than 30, it has to be normally distributed in order for me to be able to use any of the tools here. So they need to know, are we using a t-distribution or the standard normal distribution, right? Are we using the t or the z? They gave us a sample standard deviation rather than a population, so that means we are using a t-distribution. And we are allowed to use it because we did meet the criteria, right? If we go through the checklist, they are, it was a random sample, the population standard deviation was unknown, and we were either normally distributed or our n was greater than or equal to 30. We were normally distributed, so we are okay to use that. Okay, then they want us to actually do it. So we're going to go stat test. This is a t interval. Our sample mean is 3.52. Our sample standard deviation is 0.41. Our sample size is only 11, and we want to be 95% confident. Okay, so we get our interval, and then they want us to interpret that. Again, we got to make sure we're saying it the right way. With 95% confidence, it can be said that the population mean is between the bounds of the confidence interval, right? Remember what we're finding here. We're saying that the population mean, we can say with 95% certainty, with 95% confidence, is between those bounds. All right, a survey of 100 fatal accidents showed that 32 were alcohol related. Find a point estimate for P, the population proportion of accidents that were alcohol related. Okay, so now we're finally getting into the proportion problems, which I'm gonna remind you here. When we're doing these, if we're trying to find a confidence interval, we're going to use one prop z int. Okay, but it's not actually asking us for a confidence interval for the population proportion. It just wants us to find the point estimate. So the point estimate for the population proportion is just p hat, right? Which is just x over n. So I should have gone back through and I should have written that x is 32, right? 32 were alcohol related. So 32 out of the 100 were alcohol related. It's going to want it as a decimal. So we have 0.32. So remember that the point estimate for the population is your p hat, which is your x over n. All right. A survey of 2,090 golfers showed that 302 of them, that's a particular value, that's an x value, 302 of them, excuse me, are left-handed. Find a point estimate for the population proportion, which before I read anything else, the point estimate is p hat, which is x over n. Okay, so find a point estimate for population proportion, p, population proportion, of golfers that are left-handed. It gave us how many of them were left-handed. So it's not like it gave us left-handed and asked us for the point estimate for right-handedness, which we could do, but you have to make sure that you're reading what they gave you and what they're asking for. So what they asked for is actually what they gave us. So that's 302 out of the 2090. So we just pop that in to our calculator and we round to how many ever decimals they tell us to go. Okay. All right, not too bad. Okay, a researcher at a major hospital wishes to estimate the proportion, right? These are the words you're looking out for to tell you what kind of a problem this is, proportion, of the adult population of the United States that has high blood pressure. How large a sample is needed? So we're going to be finding N, right? How large a sample is needed in order to be 98% confident, 0.98, that the sample proportion will not differ from the true proportion by more than 2%. Okay, so what did they just give us here? They just gave us our margin of error. They just gave us our error. When you are given that, you have to write it as a decimal. Okay, you cannot put 2 here. You have to put 0.02. Your E always has to be written as a decimal. If you forget and you write it as 2 instead of 0.02, you're going to get the wrong number. Okay, so we go back to our formulas and we say, okay, well, what formula am I using here, right? This is not something that I can just plug into the calculator. This is a formula that I'm going to have to fill in. So right here on page 324 is our formula. I don't think we've done one of these so far. So a couple of things to point out here. So, and I'll rewrite this on the page in just a minute here, but it's reminding us that if n is in a whole number, we have to round up, right? We talked about that before. We're talking about the number of people needed in a study, so you always have to go up to a whole number. But another thing that's important to note is that if the this formula assumes that you have preliminary estimates of p hat and q hat, but if you don't, that's okay. You can just use 0.5 and 0.5, okay? So if they're not giving you a p hat and a q hat to use, you have to use 0.5 and 0.5. So you have to remember that. In fact, I think, yeah, this problem, they didn't give us a p hat and a q hat, right? So we have to use 0.5 and 0.5 for that. So again, we're going to write out our formula. P hat times q hat times the z-score for the confidence interval over the error squared. So let's go ahead and label all of these things. Okay, p hat. So it didn't tell us what that was. It didn't give us an x over n. If it didn't give us that, then we have to assume that it is 0.5. And remember that q hat is 1 minus p hat. So 1 minus 0.5 is 0.5, right? We have our E already, okay? What we need to find is our z-score, right? So remember that that is, just a quick refresher here, that is based on our confidence level of 98%, okay? But that's 98% in the middle here, okay? So 98% in the middle means that each of these, well, sorry, both of these together is 2%, right? Because the area under the curve is 1. So 98% in the middle. So the two sides together are 2%. So each side individually is 1%, right? And we might need to know that if we're just looking it up in the standard table, because the standard table only gives us the area to the left, not the area in the center, but the area to the left. So the area in the center is 98% or 0.98, sorry. The area to the left is 0.98 plus 0.01. So that's 0.99. So when we go to look that up in the table, in the, hold on just one second. All right, thanks for your patience, guys. We have gone over on time, but I promise we're almost done. Okay, so if we look it up in the table, we are going to get 2.33, right? So if you wanted to do it in your calculator, oops, sorry, would help if I actually put this up here. Okay, so we go second vars, we're going to go to inverse norm, and if we want to do the area in the center, this is 0.98, right? So this is 0.98 in the center is going to give us 2.33 if we go to 2 decimal places, because remember it's giving you the z-score, the negative z-score over here and the positive z-score over here. Or if for some reason maybe they're giving you something like they're showing you this, then you go inverse norm and the area is 0.99 if we're looking at the area to the left, right? Which again, if we round, goes to the 2.33. So either way, you're getting the 2.33. So now we have all of the values that we need. So we're going to plug all of them in. So we have n equals p hat times q hat times the z-score over the error, which always has to be in decimal form, squared. I don't know why parentheses went down so far. So again, just kind of make sure that you're plugging things in correctly to the calculator. And we're getting this number, right? This is our n, 3.0625, and then we say n is the number of people I need in a study. I can't have 0.0625 of a person, and I can't have 3393 because that's not enough. Because remember, this is the bare minimum that we need in order to be 98% confident that they don't differ by more than 2%. So we have to take this number and go up to the next whole number. Okay. All right, number 20. A researcher wishes to estimate the number of households with 2 cars. How large a sample size? Again, we're saying n is what? Is needed in order to be 98% confident that the sample proportion, so again, this is telling us which formula we need to use, that the sample proportion will not differ from the true proportion by more than 4%. So that is our error, that is our E. And again, you always have to take this 4% when we're talking about error, you always have to turn that into the decimal. A previous study indicates that the proportion of households with 2 cars is 19%. So in this case, they've given us a p hat. Again, you have to turn that into a decimal here. So if we have p hat, we can find q hat, right? So now we just need to find our z-score, right? Because here is our formula, and we have everything we need but the z-score. So again, the z-score, excuse me, corresponds to your confidence level. Okay. And we just had the same one, right? 98%. That was the last one. So we know that it's 2.33 because we just did that in the last one. So now we can plug it in. So instead of 0.5 and 0.5, which is what we would have to assume if we weren't given any other information, we were given the p hat. So we're going to plug these in. Okay. And we have this n value. It goes on for a few more decimals. And we remember, okay, n is the number of households that we need to look at. We can't have a decimal. This is the bare minimum. So we have to go up to the next whole number. Okay. So you got to remember this formula. Okay, 21. Let P be the population proportion for the following condition. The point estimates for P, or I'm sorry, find the point estimates for P and Q. Okay, so a study of, so this is N, 4237 adults from country A. So this number, this is our X, think that mainstream media is more interested in making money than in telling the truth. So they've told us that this is the condition that we want to find the population proportion for. So the point estimate for the population proportion is p hat, which is x over n. So we're just going to plug that into our calculator. And we get this number. Okay, great. So that's p hat. So remember, q hat is just the complement of that, right? 1 minus p hat. So there's two ways that you can find this. The short way is to say, well, I've already got this, so I can just do 1 minus this. So in the calculator, you do 1 minus, and then right there where it says answer above this button, you say second, and then this, and it'll use the answer from the previous problem. So I'm going to go second answer, and it says, okay, 1 minus the thing that I got up here. And that way I'm not rounding at all, right? And that's going to be the fastest way to get your Q hat. The other way is to say, okay, well, if 2486, if that number of people said that think that the media is more interested in making money than telling the truth, then that means the rest of the people in the survey do not think that. So out of the 4,237 people, if I subtract the number of people that do think that, I'll get the number of people that don't think that. And I can put that over my 4,237, right? So that's how many people don't think that. And so I take that and divide it by the sample size, and that gives me my p hat, or I'm sorry, my q hat. So that's another way that you can get that, depending on what information they're giving you. So again, in our case, it's faster to just, okay, once I find this number, just do 1 minus that number. But if you weren't given that, this might be an option too. All right, almost done. In a survey of 2,266 adults, that's our N, 2266. Would help if you guys could see that. 705 say they believe in UFOs. Okay, construct a 99% confidence interval for the population proportion of adults who believe in UFOs. So we are doing a confidence interval for a population proportion. Remember what we're finding here, right? We're doing the population proportion. We're going to be a certain percentage confident that the population proportion falls between two values. Those values are the point estimate minus some error and the point estimate plus some error. But we're going to have our calculator do all of that for us. So again, let me go back to that page. How are we finding that? Stat test A, 1 prop Z int, right? Because that's what we do when we have the population proportion that we're trying to find. Okay. All right. So we're going to go stat, we're going to go tests, and then I think I've showed you guys this before, but in case you didn't see it, I'm going to move this up here. I can either arrow down to the A, 1 prop Z int, or if I'm back up here at the top, so I want to do A, which is right here in yellow. The lighting makes it hard to see that, but right here in yellow is A. So kind of like I can do second to do what's above a button, I can do alpha to do the letter above the button. So I'm going to do alpha and then this button because this is where A is above and it goes directly to it. Okay, so it needs my X value, my sample size, and my confidence level, which is everything they gave us. Right? So that's 705. Our sample size is 2266, and our confidence level is 0.99. Okay, so we get our numbers here, and then they want us to interpret the results. So with 99% confidence, it can be said that the population proportion of adults who believe in UFOs is between the endpoints of the given confidence interval. Okay. All right, so for this problem, so every time you guys do these homeworks, they're going to spit out slightly different numbers for you. Right, not everybody's going to have the exact same numbers. For this one, if you happen to get this particular uh, number, so if they want you to find within 5% of the true proportion, it's got the wrong answer here. Okay, so if the question on your homework doesn't look exactly like this, then you're probably fine. But if the question on your homework looks exactly like this and you get it wrong, reach out to your instructor, because there's a little bit of a glitch there. Also, if you're going through and you can't figure out why something is wrong, don't hesitate to reach out to the instructor and say, you know, I don't know what's going on here, or come into the ASC and we can help figure it out. It's very rare that things are wrong in the textbook or wrong, in the online version of the textbook and the homework that you guys do, but it does happen from time to time. So it's not completely unheard of. All right, so a researcher wishes to estimate with 99% confidence. So again, we take that, we turn it into the decimal. The population proportion, so again, that's telling us what kind of a problem we're doing, of adults who support labeling legislation for genetically modified organisms. Her estimate must be accurate within 5% of the true proportion. So again, we've talked about that's our error. We have to make sure that we write that as 0.05. You have to turn that into a decimal. When we're talking about error, you have to turn it into the decimal version. You cannot write 5, you have to write 0.05. Okay. All right, so it's telling us we've got several things we're going to do here. So A, no preliminary estimate is available. Find the minimum sample size needed. So again, we have to say, okay, well, what's our formula here? Actually, I've kind of run out of room here. So the formula for our sample size is p hat times q hat. We need the z-score over the error in decimal form, and then we're going to square that, right? So when we are not given a p hat and a q hat, remember what we have to assume that they are. We have to write them as 0.5, okay? All right, and then for our z-score, so remember that's related to our confidence interval of 0.99. So if we go to our table here, our lovely table that gives us some very common levels of confidence that we're going to be using. We have a confidence level of 0.99. So that tells us that our corresponding z-score is 2.575. Okay, confidence, the area in the center there, 2.575. All right. All right, so we're going to take all this information, we're going to plug it into our formula. N equals p hat, that's 0.5, q hat, that's 0.5, z-score 2.575, our error 0.05, remember has to be the decimal, and then square it. So these sample sizes, anytime you're finding the minimum sample size, you've got to know your formula and you've got to find your z-score, right? So it takes a little bit more work than just plugging things into the calculator. But once you've found all your values, once you've identified the z-score, then yes, you're plugging it into the calculator. All right, so we have 0.5 times 0.5, and then we have 2.575 over 0.05, and we're squaring that. So we get 663.0625, but remember, I cannot have 0.0625 of a person, and since this is the bare minimum needed, I cannot go down to 663, so I have to go up to 664. So you'll notice for this particular one, they have 666. So this would be the correct answer. So again, if your homework problem isn't exactly this, then you should be fine. One of the instructors checked, and when you have a 4%, then the answer that they provide is the right one. Okay, but that's not all it's asking, because then in part B, it says, find the minimum sample size needed using a prior study that found that 74% of the respondents said they support labeling legislation for GMOs. So now, instead of having to assume that P hat and Q hat are 0.5, they're giving us that P hat is 0.74, which means that Q hat is 1 minus 0.74, which is 0.26, right? Okay, so everything else is the same, right? So plug everything in. Yeah, 74%. Okay. Again, our error of 0.05, you have to make sure that that is written as a decimal. Oh, apologies. Here we go. Okay, so we're getting 5, 10, and some change, which, what do we have to do to that? Go up to the next whole number. Even if this was 0.0001, we'd still have to go up to the next whole number because this is the bare minimum that we need. And if we go down to 510, we're not meeting the threshold. We have to go up to 511 because we're talking about the number of people. So again, if your homework has this particular combination of numbers that it's asking you about, this is going to show up incorrectly. It should be 511. And then how do the results compare? So remember what the difference was here. So in the first one, we had no background information, right? We didn't have a previous study. We were having to assume 0.5 and 0.5 for the P hat and the Q hat. So when we did that, we needed 664 people as a minimum sample size in order to be 99% confident that the true population proportion was going to be within 5%. Okay, but if we're given some of that information, if we're given a P hat and a Q hat from a previous study, then what happened to our minimum sample size needed? It went down, right? It reduced. We don't need as many people to be the same amount of confident. Okay, so having an estimate of that population proportion, it reduces the minimum sample size needed. Okay. All right. And last but not least, number 24, researcher wishes to estimate with 90% confidence. Again, we put that as decimal. The population proportion, that's telling us what kind of a problem we have here, of families who eat fast food at least once a week. Her estimate must be accurate within 2%. of the population proportion. So again, that is our error, 0.02. Our margin of error is 0.02. We have to write that as a decimal. We cannot leave it as 2. So similar to the previous one, where the first thing it wants us to do is for us to have no preliminary estimate and to find the minimum sample size. So again, we're dealing with that same formula, right? We have n is equal to p hat times q hat over e squared. So we need some of these values, right? We need a p hat. Well, if we don't have any preliminary estimates, we have to assume a 0.5 and a 0.5. And then we need the z-score, which again, that is dependent on, in fact, I'm going to write it next to the confidence level, because that's where we're getting that from. That leads us to a z-score based on that confidence level. So let's go back. So when we have a confidence level of 0.9, our corresponding z-score is 1.645. Or again, if we wanted to find that value on the calculator, we go second vars. Sorry, let me do that again. So second vars, okay. And then we go inverse norm. And then we have to make sure that we're telling us this area, this is in the center. This is the center area. And it gives us because again, remember what we're finding here is the center area. So it's giving us the negative z-score and the positive z-score, which if we go to 3 decimals is 1.645. Okay. So it just depends on whatever's faster for you to look up. It's when they give you this table, it's got your common confidence critical values with your confidence levels. It's super fast to just look at it. So if you have one of these levels of confidence, it's probably going to be faster just to look at the table than it is to plug it into your calculator. But you'll still get the same thing. Okay, so now that we have that, now we can plug all this in. We have, again, we had to assume a p hat and a q hat of 0.5. We've got our z-score, which we used our confidence level to get. Our error is the decimal form of that percentage, 0.02, rather than just the number 2, and then we square that. Okay, so we get this number, 1691 and some change. And then we say, oh, right, this is supposed to be the number of people. I can't have a part of a person. This is the bare minimum number of people. So I can't go down to 1691. I have to go up to 1692. Okay. Then, just like the last problem, they're saying, hey, now you have information about a prior study. 22% of the respondents said that they eat fast food 4 to 6 times a week. So eating fast food 4 to 6 times a week, well, that's at least once per week. So we can use that as our p hat is now 0.22. And our q hat is 1 minus 0.22. So now we say when I have some of this background information, now, oops, 645. And before we plug this in, what do you guys think is going to happen to our sample size? Oh, well, I forgot that it actually shows you right there, but it's going to be less, right? We don't need as many people when we have more information, right? So 0.22, 0.78. All right, so again, 1160 and some change for blah, 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 blah. What matters is I take this and I go up to the next whole number because this is number of people. This is the bare minimum I need, and I have to go up. And again, how do they compare? If we have an estimate of the population proportion, it reduces the minimum sample size needed. Okay. All right, so that, yes, that was the last problem. So as usual, we have gone way over on time. So I'm going to call it there. But again, you guys can, if you have additional questions, you can email me. You can use the live chat on the ASC's website. You can go into any of the academic support centers um, and, uh, and get help from the people that are there. And you can reach out to your instructor as well. All right, you're welcome, Kendra. I will email you guys the recording, and hopefully this helped and you guys feel prepared to take your test starting tomorrow. All right. Thanks so much, guys.